Right, hello then guys. Just showing you basically my my latest project, I suppose. Right, let's get things started. I'm going to tell you a little bit about it. Some of you guys will recognise what it is, some of you guys might not know. It is a Mozilla driver, also known as a ZVS, a zero voltage switching driver. Most people would run flyback transformers from it, and you know, they're pretty good for getting a good output on flyback transformers and whatnot, and also induction heaters and things like that. Now I'm taking the normal, like you'd have here, you've probably all seen it before. There's the normal schematic for a ZVS. And you're probably wondering what these are here. These are where I will be tapping off, and thanks to HighVoltageProjects for doing a little bit of calculations and finding out for me. They're going to be the taps to go to the gates of a further 8 MOSFETs. And basically they're going to tap off here with a 5 ohm resistor, and that will be going to my gate. I obviously don't have a picture for that. This is what people would generally do, just parallel them up. But I'm going to be adding a Zener diode across here, the same as you would on the two that you'd normally have. Okay. There is also a bit of a modification that has been done and has proven to give a 35% increase in power, and that is on where you'd normally have 5 turns on the primary with a centre tap, 5 turns, so there's 10 altogether. So you basically have that wrapped around a ferrite core. You might just be able to see, actually I have one sort of done there. I don't know whether you'll actually be able to make that out. That's centre tapped, 5 brown and 5 blue. As you can see, just there is a fairly standardish size ferrite core. There's the next size up, and this one here is twice the size. And as you can see, the cable coming from that is as big as my finger, so it's actually high voltage and high current, which I hope to have a play with once this driver is built. I actually built a driver last week, I think it was last week. I'm going to be completely honest with you guys, don't want to be a downer. I was in a car accident yesterday. I've got pretty severe whiplash, I've got to go and have physio. Unfortunately work on this has stopped. This is as far as I've got with it. Basically I've got a load of MOSFETs all sat there waiting with the Zener diodes, and they're actually all pre-bent to fit in some rather random things. I'll just tip them off here. So I am sorry guys, I wanted to show you this because this is my project, you know, this is what I wanted to do. It's going to have to stop for a little while. This is what I'm using to connect the MOSFETs into. It's going to be a bit of a plug and play jobby, but they've all got to be cut out, and as I said, at the moment I can't be doing any of it. I'm really struggling at the moment, but on the brighter side, you know, I should have a really nice driver when it's all finished. Now the only thing I've got to actually do to this to make it better is obviously add the other MOSFETs. The other thing I need to do, sort out a capacitor. I mean, I've just got 2 here with a switch, which is off a shit one that I had before. But I've got this, which probably you might be thinking, what the hell is that? I will try and show you in a bit more closer detail by zooming in. Right, now if you know anything about ZVS drivers, you've got 3 outputs. You've got your centre tap, where you'd go to your centre tap of your primaries that would go on the ferrite if you were taking it to a ferrite for running an induction heater or something, or that would go around the ferrite of a flyback. So you've got your centre tap in your other two. Now what this filter does that I've put together is it's supposed to stop back spikes, high voltage back spikes, getting back to the MOSFETs and killing them. So we've got one wire there, and one wire which isn't in there. I'm not sure any of them in there properly, it's just been put there. But basically what this consists of is there's the 3 wires that splits, goes into here, and we have one neon that goes from outside to outside, so it's from there to there. We have another 2 neons, one going from here to there and one going from here to there. And we've also got exactly the same configuration with, if you can see it, if it'll focus in, with some spark gaps. So we've got these 2 here are joined in the middle, and they go from edge to middle, from middle to edge. Got this one here that goes from outside to outside, and this one here which is a slightly higher voltage just in case it goes over, as further protection, and this is outside to outside as well, not actually to the centre. And for the bottom of that, it's all pretty bog standard, solder, big thick chunks of solder, and some lovely hot snot, you know. But in actual fact, I haven't really seen people using these type spark gaps. I don't really know why, because as far as I'm aware, they're, you know, that's what they're designed for. But the only problem with using these neons is they actually light up at 20 volts. They can take 240 with the resistor that's in them, but they're actually lighting up at 20 volts. And there's, you know, I can put them on 20 volt power supply and they light up. So to make them actually effective, I need to raise the resistor, the actual I can't think, sorry guys, you know what I'm talking about. The resistance of the resistor, there you go, that'll do. You get what I'm talking about anyway. So that is my project. I'm gonna have to maybe retrack something because I don't know whether I have mentioned it or not. I think I might have done, but some of you guys could be wondering what this is here and this is here. They are a replacement diode for these. They're actually designed for induction heaters. They're ultra fast switching and they're at silly volts and silly amps. And the whole point of this basically is just to learn how these things work, because I'm not really into electronics myself, and that sounds silly because I love high voltage. But I've got bored of high voltage. It's boring making arcs. I want to make my Tesla coil really, love to, but it's taking time and obviously I can't do it, especially at the moment. I can't really do anything, so yeah, basically I thought I'd just show you that, let you know how I'm getting on. I would have said it's going to be a few weeks before anything else happens with it, but yeah, that's the plan, that's what's happening. So if you've got any comments, got any suggestions on how I can make it better, how I can make it more resilient. No, I don't want to go the IGBT route, by the way. IGBTs are good, they're also wank, and I don't really want to be blowing up the good IGBTs that I do have for a ZVS driver, which I just want to play about with. It's just something to do which isn't too much, like, you know, strain. But it's going to be a fun project, but as I say, it's going to be a little while before I can get back onto the project. So yeah, as I say, if anyone's got any suggestions on how to make it better, what I can upgrade, is there anything else they can think of that I can do to get more power, make it, you know, we should be able to handle 2.2 kilowatts at the moment, with 6 MOSFETs. As I say, I'm going to have 10 in total. It's just for fun, it's just for the shits and giggles, you know. Got a big old bag of MOSFETs here, all 260Ns, got to get used. So thanks for watching, please comment, like, subscribe. Thanks.